Question number 1. There are different types of electromagnetic waves. 1.1 is an A1 question, and this question is from the topic of type of electromagnetic waves. What do all electromagnetic waves transfer? We must know that all electromagnetic waves they transfer energy. These waves do not transfer matter, charge, or the sound. They can transfer only energy from one place to another place. So among all these options, the EM waves can transfer only energy from one place to another place. The correct option is energy. 1.2 is an A1 question. It is also a knowledge based question, and this question is again from the topic of type of electromagnetic waves. Complete the sentence. The options are given here. Different types of electromagnetic waves have different frequency. If we use the following diagram, we can see that this is the EM spectrum. In the EM spectrum, we know that different waves have different frequency and they have different size of the wave. Different size mean the wavelength. So different types of electromagnetic waves have different frequency, mean number of waves per second, and they have different wavelengths. So if you go from the left side to the right side of the electromagnetic spectrum, we can see that the size of the wave is reducing, but the number of the waves is increasing. So we will say that the frequency will increase and the wavelength will decrease. So different types of electromagnetic waves have different frequency and are different wavelength. All the EM waves they have the same speed, that is speed of light 3 into 10 raised power 8 meter per second, and they are not carrying any kind of charge with them. 1.3 is an A1 question again, and this question is from the topic of type of electromagnetic waves. Figure number 1 shows the electromagnetic spectrum. We have electromagnetic spectrum, and the electromagnetic spectrum has 7 waves. So we have radio waves, microwaves, infrared radiation, and A is the visible light, the ultraviolet radiation, X-rays, and gamma radiations. The student must remember all of these radiations. So an electromagnetic spectrum has radio, micro, infrared, visible light, ultraviolet radiation, X-rays, and gamma rays. 1.4 is an A1 question. It is again a knowledge-based question, and this question is from the topic of uses and applications of electromagnetic waves. Different types of electromagnetic waves have different uses. Draw one line from each type of electromagnetic wave to its use. So different uses are given here and different kind of electromagnetic waves are given. The microwaves are used for the communication. Therefore, the option is given here for the satellite communication because satellites are present outside the earth. Therefore, we are using microwaves because they can pass through the earth atmosphere to the satellites in the space. Therefore, microwaves are used for satellite communication. Ultraviolet radiations are used for the energy efficient lamps where the fluorescent material is present in the light. Whereas the X-rays are used for imaging the bones in the hospitals, so we can see the fractures or the broken bones in the hospital. The electrical heaters need the option the thermal radiation, which is not given here. Therefore, we are given microwaves, ultraviolet radiations, and X-rays. Question number 2. A student investigated how the color of a surface affects the power of the infrared radiation emitted by the surface. The figure number 2 shows the equipment used. We can see here the infrared detector is present here, thermometers are present, miring cylinders, black surface flask, a shiny white surface flask is present, and electric kettle is given in figure number 2. The infrared detector measures the power of the infrared radiations emitted by the flask. The student poured hot water into each flask, the black surface flask and the shiny white surface flask. What should the student do to reduce the risk of burning herself with the hot water? This question is from the topic of EM waves. The student want to pour the hot water from the kettle into the miring cylinder. She should use the heat-proof gloves so that she's not going to burn herself. She can use the funnel to the mining cylinder and it can pour into the mining cylinder easily. She should stand up when she is pouring the water from the electric kettle into the mining cylinder instead of sitting. She should keep the mining cylinder away from her body so that it is not going to burn her. Let's see the model answer. Using the heat-proof gloves, using a funnel to pour the hot water slowly into the flask, or stand up while she is pouring the water in the flask, or keep the flask and the funnel at an arm distance while pouring. So different options are given here for the students. For the exam point of view, they can use one of the options to get 1 mark. 2.2 is an AO1 question. It is a knowledge based question, and this question is from the topic of properties of EM waves. Describe how the student should use the equipment in figure number 2 to compare the power of the infrared radiations emitted by each surface. It is mentioned here, describe. The student should not explain the answer, they should just mention how she is performing the experiment. The student need not to explain or give the reason for the answer. The student will use the hot water from the electric kettle and she will pour it into the mining cylinder and measure the volume of the water which she is going to use in her experiment. And she is going to use the same volume of the water in both flasks, the black surface flask and the white shiny surface flask. With the help of the thermometers, she is going to measure the initial temperature of both of the flasks. The infrared detector will help her to find the value of the radiations emitted from each flask. Let's see the model answer. The student will use the hot water from the electric kettle for the experiment. With the help of the mining cylinder, she will add same volume of water in each flask. The student will use the thermometer to ensure that the initial temperature of water in each flask is same. She will point the infrared detector for each flask at the same distance to measure the power of infrared radiations from each flask and compare the results. A student investigated how the power of the infrared radiation emitted from a flask changed with time. Table number 1 shows the results. We can see here the time is given in seconds where the power is given in watts. We can see in our table number 1, as the time is passing, the value of the power is decreasing. We can see from here the change in time is mentioned for every 60 seconds, whereas change in power we can see here with the time it is reducing here from 8 to 7, then 6, the 5, 4, 3, 2, and at the end we will get 1. 2.3 is an AO3 question. Describe the pattern shown by the data in table number 1. And this question is again from the topic of electromagnetic waves. We can see here from the table number 1, as the time is passing, the power of the infrared radiation is decreasing. And the change in time is given here for every 60 seconds. Let's see the model answer. As the time is increasing or the time is passing, the power of infrared radiation is decreasing. You can see here the power is decreasing. For every 60 seconds, the reading of the power on the infrared detector is decreasing, which is very obvious from the table number 1. What is the most likely value for the power of the infrared radiation emitted after 480 seconds? This question is again from the topic of EM waves. Use the table number 1. If we go back to table number 1, we know that the decrease is going on for every 60 seconds. 480 seconds, we need to find the value of power. We can see here the difference is going on between the numbers, that is 8, 7, 6, 5, 4, 3, 2, and the one difference is coming here. The answer will be 4.4. We know that the difference is coming here, that is 1. So the correct option is 4.4 watts. A Leslie cube is used to demonstrate that different surfaces emit different amounts of infrared radiations. Figure number 3 shows an infrared detector and a Leslie cube filled with the hot water. We know that the infrared radiation is going to find the radiations emitted by the surface. We can see different surfaces of the Leslie cube: matte white, matte black surface, shiny silver surface, and shiny black surface. The infrared detector will help us to find the value of the radiations emitted by each surface. Give one advantage of using Leslie cube rather than the experiment in the figure number 2 on the page number 4. This question is from the topic of EM waves and it is an AO3 question. By using the Leslie cube in the investigation, the volume of water is same for all sides of the cube. It means the temperature of the water is same for all sides of the cube. More surfaces can be tested at the same time, and it reduces the chances of error and give the accuracy in our procedure. The student doesn't need to repeat the experiment again and again for all sides. Let's see the model answer. The volume of water is same for all sides of the cube because the water is added into the Leslie cube and the temperature of the water is same for all sides of the cube. More surfaces are tested at the same time because it has the water which at the same temperature for all sides. The student does not need to repeat the whole procedure for all sides. 2.6 is an AO3 question, and this question is again from the topic of EM waves. The teacher improved the demonstrations by using the 4 infrared detectors connected to a data logger and a computer. Each detector was pointed at a different surface of the Leslie cube. The distance between the surface and the detector was same in each case. Give 2 reasons why this improved the demonstration. If we use infrared detector which is an equidistance from all sides and we're using 4 infrared detectors, it means that each infrared detector is going to detect the reading at the same time, and it will be very easy for the student to investigate the radiations emitted from each side of the cube. Let's see the model answer. The measurement is taken at each time by all detectors because the student is not changing or moving one detector around all sides of the cube. This will help the student to have more accurate readings of the result at the same time. Question number 3. Figure number 4 shows an apple hanging from a tree. The X mark the center of mass of the apple. The center of the mass is a place where the whole weight of the object is lying. 3.1 is an AO2 question, and this question is from the topic of gravity. Draw an arrow on figure number 4 to represent the weight of the apple. The weight is always acting downward due to the pull of the earth. X is the point that is called the center of the mass where the whole weight of the object is lying. Therefore, the arrow is acting downward. So we will draw the arrow from the point X downward towards the ground or towards the earth. So this red arrow is showing the weight of the apple acting downward. 3.2 is an AO2 question. It's a mathematical question where the student needs to make a calculation. And this question is again from the topic of gravity. The apple has a mass of 0.150 kilograms. The value of G is already given, 9.8 Newton per kilogram. Calculate the weight of the apple. The equation is already given here. The mass is given, that is 0.150 kilograms. The value of G is already given here, 9.8 Newton per kilogram. We need to find the weight. We need to substitute both the values here for the mass and for the gravitational field. We need to use the calculator to find the weight of the apple. Let's see the model answer. We know that weight is equal to mass into the gravitational field strength. The value of mass is 0.150 and the value of G is 9.8 Newton per kilogram. We will multiply them together. The answer is 1.479 Newton. So the weight of the apple is 1.47 Newton. The marks distribution is given along the steps. 3.3 is an AO1 question. The apple in figure number 4 is stationary. We can see here in figure number 4, the apple is stationary. Why is the apple stationary? Why it is not moving? Why it is not falling down? What is the reason? We know that the weight of the apple is acting downward, but the apple is attached with the branch. Therefore, the branch is giving the support, and support is in the opposite direction, and that is the reason the apple is not moving downward. We will say that the net force acting on the apple is zero because the weight is acting downward, whereas the support is acting upward. So total resultant force on the apple is zero. So the correct option is the resultant force on the apple is zero. When the apple is ripe, it falls from the tree and accelerates towards the ground. 3.4 is an A1 question. Why does the apple accelerates? This question is from the topic of Newton's second law. So it is moving downwards due to the acting force is the weight, and the weight is due to the pull of the earth. So the force acting due to the pull of the earth, that is called weight. As there is no support from the branch, therefore there is only one force is acting, which is downward, that is the weight of the apple. So the resultant force acting on the apple is the downward force, which is due to the pull of the earth. The correct option is the resultant force on the apple is downwards. 3.5 is an AO2 question. The acceleration of the apple is 9.8 meter per second square. The velocity of the apple changes from 0 to 4.9 meter per second. Calculate the time taken for the apple to fall to the ground. We need to find the time, and the equation is already given here for the student. Time taken is equal to change in velocity over acceleration. We already given here the value of g, that is 9.8 meter per second square, or acceleration due to gravity. The initial velocity that is given here is 0, and the final velocity is 4.9 meter per second. Students need to find the time taken. So we need to substitute all the values in our equation, or in the formula we can find the value of time. Let's see the model answer. Time is equal to change in velocity. So we know that the time is equal to final velocity minus initial velocity over the value of g, means acceleration due to gravity. The final velocity is 4.9 minus initial velocity is 0, and the value of g is 9.8. We will use the calculator. With the help of the calculator, the answer is 0.5 seconds. So the apple will take 0.5 seconds to reach the ground. The marks distribution is given along the steps. Question number 4. Figure number 5 shows a compass. The tip of the compass is showing the north pole of the compass. 4.1 is an AO2 question. Why does the compass always point in the same direction when it is not near a magnet? If the magnet is not present here, even the tip of the compass is pointing towards a specific direction. The reason behind it is the tip of the compass is made up of magnetic material, and it is always towards the direction of the earth magnetic field. Because the earth has magnetic field around it, therefore it is pointing towards the earth magnetic field even there is no magnet is present near the compass. The correct option is the earth has a magnetic field, and this compass is pointing towards the earth magnetic field even it is not near the magnet. One question: which material could the needle of the compass be made from? And this question is from the topic of magnetic fields. Tick one box: aluminium, copper, plastic, and steel. Among all these four, aluminium, copper, and plastic, they are non-magnetic material. Only steel is the magnetic material. The tip of the needle of the compass is made up of steel. So the correct option is steel. Figure number 6 shows a coil of wire. There is a current in the coil. The circles around the position of four compasses. One, two, three, four. We can see here a coil is present. Around the coil, we can see the field lines are generated here. The reason behind it is when the current flows through the coil is acting as a magnet. Therefore, the field lines are generated. We can see here the north pole and the south pole of these field lines. 4.3. Which statement describes the magnetic field around the coil? Tick one box. If you look into our diagram, the field is not same at all the points. It is very strong at the edges or at the corners or at the end of the coil, whereas when it is going away, the field lines are going away, they're getting weaker, they are spreading, and these field lines are not stronger as compared to the end of the coil. The field has the same strength all the points, so it is not possible. The field is stronger further away from the coil. We can see the field lines when they're going away, they are getting weaker as they're spreading out. The last option is the field is strongest at the ends of the coil. We can see here the field is stronger at the end because a large number of the field lines are present at the end of the coil. Therefore, the correct option is the field line is strongest at the ends of the coil. 4.4 is an AO2 question. Draw one arrow in each circle of the figure number 6 to show the direction of the magnetic field at the at that point. We know that the direction of the field lines always start from the north pole to the south pole of the magnet. If we go back into our figure number 6, we have the north pole, therefore the magnetic field lines have the direction going away from the north pole and they're going towards the south pole. Therefore, the direction of the field lines start from the north pole, ends at the south pole. So the arrows are drawn in the compass points on the four different places around the magnetic field of the coil. So we can see here the north pole, the field lines are coming out, whereas the south pole, the field lines are going inside. 4.5 is an AO1 question. Give two ways the magnetic field around the coil could be made stronger. To make the field line stronger around the coil, we need to add the number of turns to the coil, which will make the magnetic field around the coil stronger, or we can use the strong battery to produce more potential difference or increase the current. When the more current will flow, we will have more magnetic field around it, or we will use the iron rod or soft iron core within the coil because iron is magnetic material. When the field lines are passing through the iron piece or iron rod, so it will also become magnet. So therefore we need to add the number of the turns or increase the current, or we need to add the iron rod within the coil to make the field line stronger around the coil. Let's see the model answer. 4.5. Give two ways the magnetic field around the coil could be made stronger. Increase more current or the potential difference across the coil. Increase the number of the turns of the coil, or using soft iron rods within the coil because the iron can be easily magnetized. Therefore, we will have more magnetic field or stronger magnetic field due to the current and due to the iron rod present within the coil. Question number 5. The stopping distance of a car is the sum of the thinking distance and the braking distance. 5.1 is an AO1 question, and this question is related to thinking distance. And this question is from the topic of reaction time. Thinking distance is related to observation of the person. A person will get distracted. As the result of that, what will happen? The thinking distance is going to increase. Which two factors affect the thinking distance? Condition of the tire, driving on the wet road, mass of the car, tiredness of the driver, using a mobile phone. Thinking distance is related to the observation and the concentration of the driver. As a result of the tiredness using the mobile phone, the driver will not be able to concentrate during driving. Therefore, the correct options are tiredness of the driver and using a mobile phone. 5.2 is a combination of AO1 and AO3 question. So this question is also from the topic of reaction time. Explain why a person should not drink alcohol and then drive. We know that as a result of drinking alcohol, the person or the driver is unable to concentrate and it will take longer for the driver to make a decision. So it is a 3 mark question. So the first point is it increases the reaction time of the driver. Reaction time of the driver means the driver will take the longer time to make a decision after observing or seeing a hazard. It increasing the thinking distance of the driver. If the driver is taking more time to make a decision, the driver will cover more distance during that thinking process. As the reaction time is increasing, as a result of that, the thinking distance of the driver will also increase. If the driver is taking more time to make a decision, it means that the chances of the accident or the collision will increase. The highway code gives information on how thinking distance depends on the speed of the car. Figure number 7 shows the information as a graph. The speed of the car in meters per second is along x-axis, whereas the thinking distance in meters is along y-axis. 5.3 is an AO2 question. What is the speed of a car if the thinking distance is 16 meter? So we have to check from our figure number 7 that if the distance is 16 meter, we need to find the speed. With the help of the ruler, we're going to draw the straight line from 16 to the graph, and we will come down to the graph at the point that is 23. So for the distance of 16 meter, the speed of the car is 23 meters per second. 5.4 is an AO3 question, and this question is again from the topic of reaction time. Describe the relationship between the speed and the thinking distance. If you look here in figure number 7, the straight line is present on the graph and it shows that the speed of the car and the thinking distance, they are proportional to each other. And we can see from the graph that the straight line is passing through the origin. So it shows that the speed of the car and the thinking distance, they are directly proportional to each other, which shows that as the speed of the car is increasing, the thinking distance will increase. Let's see the model answer. The speed of the car and the thinking distance are directly proportional to each other because the straight line is passing through the region. As the speed is increasing, the thinking distance is also increasing. 5.5 is an AO2 question, and this question is from the topic of reaction time. The highway code assumes the driver's reaction time is 0.7 second. Draw a line on the figure 7 to show the relationship of a driver with a reaction time of 1.4 second. We can see here the reaction time is 0.7 second and the figure number 7 shows the relation between the thinking distance and the speed as the reaction time is 0.7 second. If the reaction time becomes double, we need to draw the line on the same graph to show the relation between the thinking distance and the speed of the car. From figure number 7, we can see that as the reaction time is double, the thinking distance will also become double. We have the triangle formula that distance is equal to speed or velocity into time. If we take this value, that is the thinking distance is 3.5 meters and the speed is 7. If we divide this one, the answer is 0.7 second. If we pick this value, that is 7 meters and the speed is 10 meter per second. If we divide distance by the speed, the time is 0.7 second. But if the time becomes 1.4 second, it means the time will become the double of the first reaction time. Here the distance is 3.5 meter, so the distance will become that is 7 meters. If the distance here is that is 7 meter on the speed of 10 meter per second, the distance will become 14 at the speed of 10 meter per second. Because 14 divided by 10, it will give me the answer 1.4 second. The time is equal to 14 divided by 10, that is 1.4 second. So which shows that if the speed is going to remain constant, it shows that if the time becomes double, the driver needs double of the thinking distance to make a decision. Therefore, the students can use 2 points to draw the line. The straight line is passing through the origin. 5.6 is an AO2 question, and this question is from the topic of acceleration. A car accelerates at 5 meter per second square over a distance of 45 meters. The initial velocity of the car is 0 meter per second. Calculate the final velocity of the car. Your answer must be up to two significant figures. The acceleration is given, the distance is already given, initial velocity u is 0 meter per second. The student need to find the final velocity. We need to use Suvat equation. With the help of the Suvat equation, we can find the final velocity. Let's see the model answer. The Suvat equation is v square minus u square, that is equal to 2as. We will substitute the values of the acceleration, distance, and velocity in our equation. V square minus 0 square is equal to 2 into the acceleration, that is 5 meter per second square, and the distance traveled is 45 meter. So V square, that is equal to 450. Taking the square root on both sides, so V is equal to 21.21320. But the demand of the question is up to two significant figures. Therefore, the first two significant figures are 21. This number 2 is less than 5, therefore we will ignore all the values present on the right side. Therefore, the final velocity of the car is 21 meter per second. The marks distribution is already given along with the steps. Question number 6, figure number 8 shows a longitudinal wave. The different parts of the waves are already mentioned. The particles are very close to each other. This part of the longitudinal wave is called compression. Where the particles are comparatively away from each other, that part of the wave is called rarefaction. So 6.1 is an AO1 question. What do the label A and B on figure number 8 represents? Choose the answer from the box. Amplitude, frequency, refraction, reflection, and wavelength. We know that the point number A is showing the particles of the medium are away from each other. This part of the wave is called rarefaction. Whereas B is the midpoint of two consecutive compressions. It is called the wavelength because it is the distance between two consecutive compressions. So the correct options are A is rarefaction and B is wavelength. 6.2 is a combination of AO2 and AO1 question, and this question is from the properties of the waves. The wave shown in figure number 8 has a frequency of 4 kHz. Calculate the period of the wave. Here the period means the time period, and the time period is represented by capital T. We know that frequency is 4 kHz. We need to convert kilohertz into hertz, and we know that kilo means 1000, so frequency is 4000 hertz. We also know that the time period is equal to 1 hour frequency. Our frequency is equal to 1 hour time period. We need to find the time period, so time period is equal to 1 hour frequency. So frequency is 1 over 4000. We need to use the calculator. Our answer is 0.00025 second. So the time period of the wave is 0.00025 seconds. The mark distribution is given along each step. 6.3 is an AO1 question, which is the knowledge based question, and this question is from the properties of the waves. Write down the equation that links frequency, wavelength, and the speed. So we have the formula, or we have the equation that speed of the wave is equal to frequency of the wave times the wavelength of the wave, or V is equal to F into lambda. 6.4 is an AO2 question, and this question is from the properties of the waves. A sound wave have a frequency of 300 Hz, travels through the air. The air has a temperature of 28 degree. Determine the wavelength of the sound. We have the formula that V is equal to F lambda. We need to find the wavelength. We have the frequency, but we don't know the speed. We need to use a figure number 9. We need to use the temperature 28 from the figure number 9 to find the value of speed of the wave. Let's see the figure number 9. In figure number 9, for the temperature of 28 degree, we will draw the straight line up to the graph, and from the graph we will go on the left side. The speed of the wave at the temperature of 28 degree Celsius is 348 meter per second. So we have the speed 348 meter per second. By using the graph, we got the speed of the wave that is 348 meter per second. We will use the formula V is equal to F lambda to find the wavelength of the wave. Let's see the model answer. V is equal to F into lambda. The speed of the wave is 348 meter per second. The frequency is already given, that is 300 Hz. We need to find the lambda. Question number 7. Figure number 10 shows competitors in the wheelchair race at London Marathon. The distance of the London Marathon is 42,000 meter. We can see here that different competitors are competing with each other in the race. 7.1 is an AO1 question, and this question is from the topic of work done and the energy. Write down the equation that links the distance, force, and the work done. Student must remember the formula, or they can use the equation sheet to find the formula which can link the work, force, and the distance. The correct formula is work done is equal to force into distance. So W is equal to force times distance, and distance is represented by small s. 7.2 is an AO2 question, and this question is again from the topic of work done and energy. During the race, the competitor works against the air resistance. The work done against the air resistance by the winner of the race was 3.36 million joules. Calculate the average air resistance acting on the winner of the race. So we need to find the value of the force, because air resistance is a force. So the amount of energy or the work done that is given here, the distance traveled by the competitor, that is 42,000 meter in the race. We need to find the air resistance. We will use 7.1, and we will use the formula work is equal to force into the distance to find the air resistance. Let's see the model answer. We know that work done that is equal to force into the distance. The value of the work done, which is already given here, that is 3.36 million. We will use the value of the work done and the distance traveled in our formula. By using the value of the work done and the distance traveled, we can find the value of the force. Rearrange the formula with the help of the calculator. We can see that force is equal to 80 Newton. 7.3 is an AO1 question, and this question is again related to the formula. Which equation links the distance traveled, speed, and the time? Student can use the equation sheet to find the relationship or equation between the distance traveled, speed, and the time. From our triangle formula, we know that distance is equal to speed into time. 7.4 is an AO2 question. The distance traveled of the London Marathon is 42,000 meter. The winning time of the race, that is 5600 seconds. Calculate the average speed of the winner of the race. So we need to find the average speed. We have been given the time, that is 5600 seconds. The distance traveled is 42,000 meter, which is already given in the beginning of the question. We need to find the average speed. So we can use 7.3 to find the value of the average speed. Let's see the model answer. In 7.3, we use the formula that distance traveled is equal to speed into time. The distance traveled is 42,000 meters. Speed we need to find, and the time taken, that is given here, 5600. So we will use both the values in our formula. By rearranging the formula, we will get 42,000 over 5600. By using the calculator, we will get the answer. Speed is equal to 7.5 meter per second. The marks distribution is given along each step. 7.5 is an AO3 question. The student need to explain the answer. And this question is again from the topic of speed. Explain why the speed of a competitor changes during the race. From figure number 10, we can see here the competitors are on the wheelchairs. In the start of the race, all the competitors are accelerating. It means the speed is high in the beginning of the race. We also know that the road is not flat, therefore the speed will somewhere increases or somewhere it decreases. There is a friction between the road and the tire, which decreases the speed of the competitor during the race. As the competitor is moving around the corner, the speed will decrease around the corner. In the start of the race, all competitors are accelerating, means the speed is increasing in the beginning of the race. The road is not flat, it means the uphill and downhill of the road. Therefore, the speed of the competitors is keep changing during the race. When the competitor is going uphill, it means the speed is decreasing. When the competitor is going downhill, it means the speed is increasing. When the competitors are moving around the corners or the bends, their speed is decreasing because they are slowing down while moving around the corner. There are resistive forces, means the friction between the road and the tire and the air resistance on the competitors, which is making the competitors slow during the race. Student can add extra points or they can use these options in the answer. The tire of the wheelchair may get punctured, making the wheelchair slow. Near the end of the race, the competitors will get tired and the speed will decrease. The competitors sometimes sprint during the race, which means that the speed of the competitors will increase during sprinting.